Technical English.
Tiếng Anh ngành kỹ thuật.
Unit 1. Systems. Recording 2.
My talk today is about FDRs and how they work. Now, as you probably know, FDR stands for Flight Data Recorder, and so it's a device used for recording data during a plane's flight. It also helps investigators to work out what went wrong if a plane crashes.
What happens if a plane crashes into the sea and sinks? How do the investigators find the FDR then?
FDRs have an underwater locator beacon. There's a sensor on the side of the beacon. When water touches the sensor, it activates the beacon.
Could you give us some details about the transmission?
Yes. The beacon sends out pulses at 37.5 kilohertz.
Can it function at the bottom of the ocean?
Yes, it can transmit sound from a depth of 14,000 feet.
Do you have to work fast in order to find the FDR?
Well, as soon as the beacon starts to transmit, it will continue for 30 days.
And how frequently is the signal transmitted?
The beacon sends out a signal once per second.
What kind of battery is used for the beacon?
It's powered by a battery with a shelf life of 6 years.
What happens after you find the FDR?
After an air accident, the flight recorder is transported to the computer lab. There, the data can be analysed. If an accident happens at sea and the flight recorder was in the water, the FDR must be transported in a container of water to keep it cool. Any other questions?
I can't see the beacon very clearly from here. What shape is it exactly?
It's cylindrical. The beacon also serves as a handle.
I heard that flight data recorders are sometimes called black boxes. Is that right?
That's correct, yes.
Then, can you explain why they're called black boxes if they're bright orange?
Yeah, well, good question. We're not sure why they're called black boxes, but we do know that the early FDRs were in fact black because they used a film-based technology. So the insides of the boxes had to be black to stop any light affecting the film. Nowadays, they're painted bright orange so that they're easier to find.
Recording 3.
Hi everyone, I'm going to demonstrate this self-inflating liferaft. This one's big enough for 8 people, though there are bigger ones for 12 people or small ones that take only 4. So, let's take a closer look at this liferaft. On top, you've got a canopy to keep out the waves and the rain. This canopy inflates automatically and it's insulated to keep the occupants warm. The floor of the raft is insulated too. The canopy has lights on top, which are water activated. It also has a device for collecting rainwater. Now, let's have a look at the automatic inflation system. First, the 2 buoyancy chambers are inflated. That's the 2 circular tyres that form the outer walls of the raft. This forces open the vinyl carrying bag. Then the canopy over the top is inflated. Then you can get in. The whole process of inflation takes 12 seconds, OK? That's just 12 seconds. Next point, stability. There's a big danger with standard life rafts that the wind will catch the life raft and capsize it, or flip it over. But on this model, there are 2 big stabilisation chambers under the floor of the life raft. Both chambers quickly fill with water from the moment of inflation. They fill in 2 stages. First, the upper chamber fills through vertical portholes in the chamber walls. At the same time, the lower chamber starts to fill. Water gets in through the bottom here, through a one-way valve which lets water in, but not out. Once these stabilisation chambers are full, you've got a stable life raft. You could find yourself in a hurricane with 10-metre high waves and winds up to 300 kilometres per hour. Even in a hurricane like that, this life raft is so stable that it's unlikely to capsize. And if a giant wave comes along and flips the life raft over, the weight of the water in the stabilization chambers will flip the life raft back up again. In other words, it rights itself at once.
Ngoại ngữ chuyên ngành.com